Okay, machine learning. So machine learning, we have already seen, right? ML or machine learning is a subset of AI that enables system to learn from data without being explicitly programmed to make decisions, right? Now, main learning, let's see main learning paradigms. So main learning paradigms means overall style or approach of learning from the data. So most important part in machine learning is data, right? Because data is everything. Data is the thing on which machine learning learns and make predictions, right? So machine learning based on the style or approach of learning is divided into four categories. First one is supervised learning. Second one is unsupervised learning. Third one is semi supervised learning. And then fourth one is reinforcement learning. Okay. So, okay, talking about supervised learning. So, what is supervised learning? So, supervised learning is something where you give a model both features and labels. So, what are features and labels? I will cover later on. But for now, you understand that features are input and labels are output. So, you have to when you are training the model, you have to give the data where both inputs and output is present. And then the model learns to map the input to output, and then it will make prediction for the new data, new incoming data. Example of supervised learning is predicting house prices when we already know past prices. We will cover all these in very detail. So, if you are getting confused or if you are not able to connect dots as of now, you just, rest assured, we'll be covering each and everything in detail. Next one is unsupervised learning. So, unsupervised learning is something where we only give features to the model and no labels, right? So, when I'm talking about features, so features are input, input, basically we call inputs as features. And then in this case, the model finds the hidden patterns or groups. So one of the example of unsupervised learning is clustering houses or dividing houses based on various categories, right? Like luxury, budget, without knowing the prices. So clustering is, classical example of unsupervised learning. Then we have semi-supervised learning, where a mix of data. So some data will have features and labels, both. Some data will just have features. So semi-supervised learning is, mix of supervised as well as unsupervised learning. Then the next one is reinforcement learning. So reinforcement learning means model learns by trial and error, and model gets rewards and penalty. So one of the example of reinforcement learning is chatbot, right? So chatbot may you might have seen, like and dislike button, right? So like and dislike button serves as the reward and penalties for the underlying, system, machine learning system. So for example, you have asked some question to the chatbot, it has generated the response and you have liked that response, you have clicked on like button. So it will take it as a reward and it will adjust to produce more responses that leads to positive rewards in future. Similarly, if you dislike the answer, then it will make sure that it will not produce such responses on which you have just disliked it in future. So this is how reinforcement learning basically, the system based on reinforcement learning works, right? Yeah, so this is about the AI fundamentals. So this is all theory as of now, right? So any doubt, I think the core concepts or the fundamentals of AI is somewhat clear to you guys, right? What is AI, then where ML, deep learning, Gen AI falls, and then what are the various algorithms. So you might have, you might have seen these terms for sure once in your life. So this is how these various terms connect in AI word. Now, the next thing that we are going to see is the various machine learning terminologies. Very important. So in machine learning, there are various terminologies, right? Feature, data set, sample, and then metadata, input, output, training data set, test data set, parameters, activation. There are a lot of terms, right? And we are going to see what all these terms actually means. So let's do one thing. Let me create a sample data set. Okay, for that I will open one sample file. Uh, ML data set. And this is an interesting topic. So let me create some sample data. I will name it as an ID, first column. Then let's say time stamp. And next column, notes, size, size in square feet. Next column, number of bedrooms, or just let me write down bedrooms. Then location, and then prices in dollars. Okay. So let me create 6 rows here. 2, 3, 4, 5, 6. Timestamp 01012025. And then just giving some random values here. Okay. Notes may let me write down some note. First entry, I will leave second one empty. Then missing bedroom, and यहाँ पे missing size. You will connect the dots once I will finish this off. Missing location and missing price. Okay, square feet में let me put some random number. 1200, 1500, 1300. यहाँ पे it is missing 1400 square feet. Then let's say 1600 square feet. Bedroom, 3 bedroom apartment, 4 bedroom apartment. This is missing. 2 bedroom apartment, 3 bedroom apartment, 4 bedroom apartment. Location में urban, suburb, then rural, then urban. This is missing, let's say, and this is suburb. Missing location, right? Prices में $350K, and then let's say $470K. This is let's say $255K. This is $250K. This is $360K. So this is my sample data. Let me format it properly. Okay. And okay. So this is my data. Now, this is how your data looks in machine learning. I mean, there are many ways. So this is actually sample text data. I would say data can be in any format, audio, video, and it can be in any format. So so as part of machine learning, our aim is to provide this data. So this has only 6 rows, but in real world examples or in real applications, we have data, some thousands and lakhs of, records in the data. And what we do, we build ML systems, which will basically feed on this data. It will go through this data, learn the pattern, and it will finally come up with a model so that in future, if you will, give let's say some information like some square feet and bedrooms and then location, if you will give to that particular trained model, it will be able to predict the price based on the learning that it has done on this data. So which is the ultimate goal of machine learning, to make prediction on the unseen data or new data, right? Why we are doing that? Let's say if we are able to build a model, I am a real estate agent or a real estate businessman, and I have this data, I have trained a model, and for future I will be able to predict the market price based on the size, bedroom, and location, right? So I'll be able to predict the market price correctly based on the learning that my machine learning model did, right? So this is how the machine learning is helpful in real world in various domains as well, right? Now, for this data, we will see various ML terminologies. Okay, so let's take a break for now, 10 minutes break, and then we will cover the various terminologies. And it's an interesting thing. So these terminologies, people, even highly experienced ML persons, highly experienced in terms of number of years I'm talking, not in terms of knowledge. So some of those people also are confused in these ML terminologies. So we will decode these terminologies one by one, and then we will proceed to the machine learning part. And when we will be covering machine learning, we will basically build the system which will basically train on this data, and then it will make the predictions. Okay, we will build those systems. So now let's take a break for 10 minutes. Hey everyone, welcome back. Okay. Now we'll see the various machine learning terminologies. Okay. So let me create a new mind map. ML terminologies. Okay. So first of all, we have dataset elements. This is something that we will see first. And in dataset elements, we have, features, non-features, labels, sample, metadata, input, uh, ground ground truth, predicted output. Okay, let's see this first. Okay. And data set. Okay, let me write down what we will be covering after data elements, data set elements. Second thing is data set splits. Third thing is model component or model components. And then we will see training process and evaluation and metrics. Okay. So first we will cover dataset elements. Cool. Okay. So this is, let's say, this is the data that I got, and this is my, first level data. So this is known as raw data set. So the data that, I mean, the complete data is known as data set, and the whole data is raw data set, because this is what the raw data is, what we have received, right? We have, some of the missing values here, and missing bedroom, missing sizes, and missing location is there, missing prices is there. So this is the raw data set. Now, when we do feature engineering, so feature engineering is known as cleaning of data. I mean, cleaning of data is, part of feature engineering, but using feature engineering, we will basically get the clean data set. So I will not talk much on feature engineering as of now. As and when required, I will cover feature engineering. But yeah, I'll just, just for the starters, I am just telling you what feature engineering is. So for example, as part of feature engineering, we have to fill the missing data. Let's say that we have these, sizes, and this one is missing, right? So what I will do, I will just take the average of all the sizes available, 1200, 1500, 1300, 1400, 1600, and then I will fill up the average approximate size after, calculating the mean or the average of all the available sizes. Let's say 1400 is, mean size that is coming up, and I have filled this data. Now here also I will take, average of the bedroom. So average of bedroom, let's say it is coming somewhere around 3. So I will just fill up 3 here. So this is cleaning of the data I'm doing, because I have to fill up the missing data here. And location, location you can, probably fill by analyzing the other data. Let's say other data as in the most occurred data. So let's say urban coming 2 times, suburb coming 2 times, rural is coming 1 time. So either urban or suburb I can keep. Let me keep it as urban. And for price again, let me take some random, average. So I'm just writing down the random numbers here, 337K. And this is also you have calculated by averaging. So compared to the, okay, now there is one more missing data here, right? So here also by human experience, you can fill this notes section, something, on your, I would say, on your judgment. So let me write down as second entry here. Okay. Now what I have done, I have filled up this information. I have filled up this size, bedrooms, location, and prices. And whatever I have done as part of feature engineering. Now, after doing feature engineering or cleaning the data that is available to me now is known as clean data set. So this is clean data set. Now let's talk about uh, feature, non-features, and label. So feature is something based on which you will, train your model, or they will serve as the input to the model. Now, if you look closely, when I will be training my model, Will the ID is something serial number or yeah, any unique identifier, ID, timestamp, and notes. Will this matter or will this hold weightage in the calculation that my model will do? No, right? Because notes can be anything, timestamp can be anything, ID can be anything. It's just that the size, bedroom, and the location is something which matters to me in order to calculate the price. Notes will not matter for the price, timestamp will not matter, ID will not matter. So the data columns or the data attribute which I am considering as an input to my model, these are known as features. And the output, I mean, there is one column which I am defining as output. So for me, the output is prices. So output is basically known as label. Okay. And then these things which are not, which don't hold value with respect for me, with respect to model calculation or doing the prediction, they are known as non-features. Okay. Now, next thing is sample. Okay. Before that, if I will talk about this whole entry, when I'm talking means every row and this entry. So this thing is known as non-feature data set, right? This is known as feature data set. And the last one is known as label data set. Okay. And then feature data set and label data set, they collectively known as modeling data set, because features as well as labels both will be used to model or to train your model in machine learning. Hence, they are collectively known as modeling data set. Any doubt? Any questions? So far, good? Anything which anyone wants to ask or add up? Okay. Now going to the next thing, samples. So sample is nothing but uh, sample is one row in the data set. Okay. So if I'll take one row in the data set, let me take this whole row. This whole row. So this is known as sample. This is known as sample. A sample. Okay. So sample is nothing but one row in a data set, and you can denote sample just by the values or by feature name and feature value pair. I mean, column and value pairs. Now samples also we can further subdivide, right? How we can subdivide? Let's take an example of last row. Okay. So the whole sample we will divide into three parts. This is one part, this is second part, and this is, sorry, this is third part. So this first part, just this part, this is known as non-feature sample. This is known as feature sample. And third one is known as label sample. right? Now, if we will, join all these together, non-feature sample plus feature sample plus label sample is nothing but simply a sample in a data set, right? But we have divided this one sample into these three categories based on non-features, feature, and label. Now, non-feature sample is something which we call as metadata. So this is supporting data, hence it is known as metadata. And feature sample is something, we call it as an input. And label sample is actually known as actual output or ground truth. Actual output. Okay. And then this is the sample, and when model will do the prediction, it will do its own calculation, it will take its time and it will do its own sweet calculation. Then we will have one more column, which will be something known as predicted price. So predicted price also what happens? So we basically train the model, and then even for the existing price, we will ask model to predict the price just to compare key price, actual price, and then predicted price. Mein how much difference is there? That's how we can calculate the effectiveness of the model, right? So predicted price, let's say some $350, and I mean there will be some values that which my model will predict, right, for the price. So this that particular thing, or one sample of it is basically known as predicted output. Predicted output, right? So any doubt, Gaurav, Sarthak, Devansh, anything? All clear?
So this predicted output, we don't call it predicted label. Like you said, the output is label. So like terminology wise, can we say this predicted label? Something
Predicted
like
label might not be the correct term, because label is something which is already labeled. Labeled as in which is already existing
okay,
thing. So we basically
okay.
use label for the ground truth or actual output. So
Mm-hmm.
predicted output is more relevant term, I would say.
Okay. Yeah.
So this is about data, right? Okay. Now, this is about the data set and then samples and non-feature sample, blah, blah, blah. This is for the data set that I have. Now, uh, we can have unseen data also, right? Unseen data, maybe it will be looking like this, looking like, one of the rows where we will be having ID and then timestamp and then notes, size, bedroom, location. And then price is something which will not be there. And once our model is trained, it will basically predict this price, right? So this is our goal for the unseen data, to predict the prices once the model learns from the data. So this unseen data, uh, so this basically the unseen data. I mean the picture that you are seeing as of now. So we can have sample in the unseen data as well. So just this is the basic concepts of data set elements. Now next thing, so let's see whether we have covered everything. Okay, we have covered features, we have covered non-features, labels, sample may be non-feature sample, which is metadata, then input, and ground truth, which is nothing but actual output, predicted output. We have covered everything here, okay? Data set elements. Next is data set split. Now, what happens when we do modeling and or when we train our data set? So this whole data we will divide into three parts: training data set, validation data set, and test data set. So for now, let's not talk about validation data set as of now. Let's just you know consider training data set and test data set. So what is training data set? Training data set means, let's say if I decide that this particular data is my training data set. So training data set is where model will go through the data, the input data, the labels, and it will find the pattern in this data so that it can learn. When it will find patterns, it will basically come up with so there are mathematical formulas which works in background, and those mathematical formulas have coefficients and various weights or variables there. So it will learn about those weights and coefficient by going through this data, and then it will come up with a final mathematical formula based on the learning that it gets from this data. So this is the training data set. So I am basically using this data set to train my model. Now test data set. So test data set, let's say that this is the test data set. So test data set is something which model never touches, during training. The main intention of keeping test data set is to check the effectiveness of the model that it has learned from the data. So my data, it will learn from this, my model, it will learn from this data, and then I will take its test, right? Like we humans do, humans give exam, right? So while learning, we'll go through some, question papers, and then, various objective question and answer. But on final exam day, we don't know the output, right? We are not aware about the output. And then we basically give the test just to see how much we have learned. So the same concept applies here also. So for testing data set, we will just check the effectiveness of the model, and we will basically ask the model to do the prediction. It will do prediction here also, even it will do prediction on the training data set also. But training data set pe when it will do prediction, it becomes biased, right? Because it already knows the output. So yahan pe bhi the chances are there that it will produce the similar output. So in real world example also it happens, right? When you are revising the objective type question and answer, and you have gone through the answers one time, then next time when you face similar question, you will be able to answer it correctly, right? Because you are biased with respect to the learning that you have done. But for the test data set, we haven't exposed the output. Hence, the more corrective measure we can take from the testing data set. So this is the importance of dividing the whole data set into training and testing data set. Now there are uh, few more terms which are epoch. So epoch is one complete pass through the entire training data set. So what happens? So when model will learn, it will go again and again, same data. It will go learn this data, this data, this data, this data. Then again, it will come first data again, second data, third data, fourth data. So the number of times it will go through the entire data set is known as epoch. So one epoch means one complete pass through. The same thing happens in real world also, right? When you study something, you will do the revision, right? So consider each revision as one of the epoch. Okay. Then we have batch or mini batch. So batch is another term. So batch means subset of training data used at a time instead of all the rows. For example, training data set, maybe it will create the batch of, let's say, one row or two row each time. It will, uh, it will use these two row first and then next two rows instead of taking all the rows at once. So this is known as batch. So yeah, so that's about data set split, right? Data set split में training data set or training data we have seen and test data we have seen. Then we have seen epoch and batch. Okay. Next comes the model components. So model components may we have term something known as model, very common term. Then we have architecture. Then we have parameters or we call them as coefficients or weights. These are almost same term. Then activation functions. And we have embeddings. Okay, let's see model first. What is model? So what I have told you, so these are input, these are output, right? So what happens? Let's take this as x1, x2, and x3. Okay, and this is y. Now, if I want to form a journal equation, I will form something like y equal to c1 into x1 plus c2 into x2 plus c3 into x3, right? Now these x1, x2, and x3 are features. Y is label or ground truth, and this c1, c2, and c3 are known as coefficients or parameters or weights, whatever you want to call. Now, as part of this uh, training process, so I have just taken a very basic example. Now, as part of this training, the aim of the model, or sorry, the aim of the learning that we are doing, machine learning here, is to find the value of these coefficients, some numerical value of these coefficient, so that using the final equation, you can predict the price, almost the same price which is there. So let's say I have calculated, or my system has calculated, 1 second. Let's say my system has done its training and it has calculated these coefficient, and let's say coefficient came as 50 x1 plus 2000 x2 plus location, let's say sorry, not location, x3 है ना यहाँ पे, तो x3, इसको let me simplify it. So y equal to 50 into size, then 2000 into bedrooms plus location. So this is the final uh, coefficients that it has calculated, and the final formula, mathematical formula, that gets finalized or that gets logged after machine learning or after the learning on the training data set and everything is done. So the final mathematical formula that evolves or that basically forms is known as model. So model is nothing but a final maths function involved, uh, uh, in final math function that you form after the learning process gets completed. So this is about models. And C1, C2, C3 that we have already seen, these are known as parameters or coefficients or weights. Okay. Then we have something known as activation function, which comes under, which will come when we will learn more on neural networks. So what the activation function is, so sigmoid, ReLU, there are many, activation functions are there. But for now, uh, Just think that activation function is basically used in neural networks to introduce the non-linearity. So what is actually the activation function? I'll cover when we will, start neural networks and deep learning. Next thing is embeddings. So embeddings, so everything on back end or under the hood is mathematics, right? In machine learning, everything is mathematics. Now, if I will look onto this feature, location feature, can I do mathematics based on these values? Urban, suburb, rural. These are text field, right? Whereas other features have numerical values, so these we can utilize in doing the mathematical calculations, right? Even price is basically the numerical value is there for the price. But for location, we don't have any numerical value, right? So embeddings is a process where we will convert these values into numerical values. So how we will basically do that? So for example, let me take location I mean, the urban location as the example. So one hot embedding is one of the method or one of the embedding that we do. So what we will do, so instead of this one column, I will divide these columns into three columns. So how I will divide? So I will name first column as location urban, second column as location suburb, and third column as location rural. Now what I will do, so wherever I have urban, so यहाँ पे there will be three columns, and urban wherever is the urban, I will put one as the number there, and rest other zero. Suburb का जब आएगा, then suburb के लिए this will be zero, this will become one, this will become zero. And rural के लिए this is zero, and this is one. So basically, uh, for these categorical feature, uh, not for categorical features. So for these, textual features, we basically convert them into the numerical value by using the concept of one hot encoding, where we basically convert each value into the numerical equivalent. So if that value is there, we will call it as one, and other we will put zero. So this is the example of embeddings. Now, if you might have seen, right? So if I talk about feature engineering now, feature engineering. So as part of feature engineering, what all comes? So, cleaning the data, right? Cleaning the data. We have done cleaning of the data. Cleaning of the data means uh, adding missing values. We have added missing values, right? Then we have basically selected features, non-features, and labels. Yeah, based on the whole data, so everything cannot be feature or everything cannot be non-feature or label. So we have to, we have to be smart enough to understand what all parts will come, constitute feature, non-features, and labels. Then we have done embeddings, right? Embeddings or one hot encoding that we have done for location, location column. So these are some of the examples, or these are some of the steps that we have taken in this particular example. And every step that we have taken here is part of feature engineering. So we are doing engineering, and we are basically, doing the engineering around, mostly around these features. So that's why it's known as feature engineering. And as part of feature engineering, cleaning the data, adding missing values, then selected feature. So everything what we are doing with respect to the data set to make it more effective is known as feature engineering. Okay. Now, what is the next thing? मॉडल कंपोनेंट्स और ट्रेनिंग प्रोसेस में फर्स्ट पार्ट इज ट्रेनिंग, देन वी हैव एल्गोरिदम, then we have overfitting, underfitting concepts, right? Yeah, I think this is enough for now. Underfitting. Okay. So training. So training, you might have known by now that model learns from data, right? So model looks at the data again and again to find patterns between features and labels, and then finally it predicts on the unseen data when it is in production, right? Algorithm. So algorithm is the method that model uses to learn. So these are gradient descent, OLS. So these are some of the algorithm that basically they teaches in advanced mathematics. So when you guys, I mean the people, the mathematic, I mean the people who do MSc and PhD in mathematics. So these concepts basically they learn these concept OLS and gradient descent uh, uh, in advanced mathematics basically. So Python under the hood uses advanced mathematics, algorithms to find the hidden patterns in the data. So that is why, so that is the beauty. This is the beauty about this is the beauty of AI, right? It is perfect amalgamation of computer science, then mathematics, then neuroscience means biology, then chemistry also, because some of the chemical reactions in the neuroscience that basically are there, they basically they basically inspired the concept of neural science also. I mean, not neural science, neural networks that are there in deep learning. So I mean, everything is been, it's brought together in AI. And as I said, so that's the beauty of it, right? And then overfitting and underfitting. So overfitting means that when you uh, evaluate your model, then your model performs very well on the training set, but it fails to do the prediction on the test set. Matlab, for example, let's say you are learning for the exam, and you have learned everything that's there in your textbook. You know each and every question and answer there, and when you are doing the revision, you are doing very good. So if they will provide you the same question, you will get 100 out of 100 marks. But apart from that, if you'll get something new in the in your exam, you fail to score there. So that is known as overfitting. Underfitting means model is too simple and predicts, it will not be able to predict. It will basically, it will not perform on the training set also. It will not perform on the testing set also. So model too simple. So in real world example, so a person who is studying, he is not able to study when he's doing, when he's learning. So when he's doing the revision, he is not able to answer what's there, what he has learned so far. And in the exam also, he will not be able to perform, right? Because he has not learned when he was doing his learning, right? So that is known as underfitting. So overfitting and underfitting are one of the most used terms in machine learning when we evaluate models. So we will see that in depth when we will create the ML models using Python. Okay. Next thing is evaluation and metrics. So evaluation and metrics में prediction, right? Prediction. So prediction is a model's output for unseen data after training, right? Then we have performance evaluation metrics. So performance evaluation metrics So we have something known as coefficient of determination, which is known as R square, then mean MAE, mean absolute error, MSE, RMSE. So these are some of the terms or some of the statistics concept which basically you use to evaluate your model. And we will learn each and every concept that I am, telling here. We will see how do we calculate these R square, MAE, MSE, RMSE, and how these concepts are used to evaluate your final models. And then, we have other evaluation metrics also. So the above one, R square, MAE, MSE, RMSE, are basically used in regression. And for the classification models, we have something known as confusion matrix and recall, F1 score, etc. So this is about performance evaluation metrics. Okay, now so this is all about ML terminologies. So very important for you guys to understand each and every concept that we have discussed, whether it's data set elements, data set splits, model components, evaluation and metrics, training process. So this basically builds your foundation of machine learning. And you have to be very clear. You should be understanding these concepts on base level if you want to, understand machine learning nicely. Okay, any doubts, anything which is not clear, or anyone wants to clarify anything that I've taught in this lecture? Okay. Okay. So do you want me to continue teaching machine learning now, or from next class, do you want me to take that on? Suggestions, please.
Yeah, we can do it from tomorrow if it's big, because we just have 10-15 minutes now.
Yeah, so what we will do from next class, we will start supervised learning. What is supervised learning? And then what are the different tasks in supervised learning? So basically regression and classification are the tasks that comes under supervised learning. We'll take the example of regression, what regression are, what are different algorithms in regression. And then what we will do, if we'll get some time tomorrow, we will write a Python code to implement a simple linear regression, basic flow for simple linear regression using Python. And we will see how we basically create model, how do we basically train the model, and then how we basically do the prediction. And then after learning about the basic flow, we will learn about statistics. Statistics is something that you might have, in your elementary mathematics, you might have learned about statistics. So time to revise that. And then using those concept of statistics, we will see how we evaluate the model. Okay. Cool. I think then that's pretty much it. So how's today's lecture?
Yeah, it was good.
Yeah, it was good. Learned some new things today.
Okay. Cool. Okay then. Thank you guys. We'll see. We will meet tomorrow then. We'll start machine learning, and we'll try to do some, Python code also tomorrow. Yeah. Thank you.
Thank you.